Hello everyone. In this video, we're going to explore a new integration technique called U substitution. Okay, and so when you look at this integral below, what you notice is that we can't use any of the integration techniques that we've learned thus far, right? Because we've learned about the integration technique for if it was the integral of x to the fourth dx, right? And we've learned like an integration technique for the integral of 2x plus 1. But we haven't learned an integration technique for a function being raised to a power, right? So in other words, looking at this is a composition of functions. And so if I was asking you to take the derivative of this function, we would be using chain rule, right? So basically U substitution is basically undoing the chain rule. It's just what you do for finding the integral of a composition of functions. So what I'm going to do here is I'm going to look at this expression, and what I'm going to do is call this inner function u. Okay, so my u is going to be 2x plus 1, and so in particular it's this piece here. Okay, and so now the next step of this technique is once you identify what your u is, and so at this point in the video it's not super obvious because we haven't done a lot of examples yet, but this has to be our u because here, what else would I really let be u? It's not very clear because this is the only function involved as far as like this being my inner function. Okay, but we will talk about more how to identify what piece I should let be u and what piece I shouldn't let be u when we look at more examples. So now I'm going to do is take the derivative of u. And so I'm going to use Leibniz notation to just say, okay, I'm taking the derivative of u with respect to x, so I'm going to write du dx is equal to, and then the derivative of 2x plus 1 just gives me 2. Okay, now what I want to do is multiply both sides by dx. Okay, because notice here that du dx is just du over dx, and so I'm just going to multiply both sides by dx, and so this leaves me with du is equal to 2 dx. Okay, and so I'm just going to highlight this in purple. And so the point of this technique here is you want to substitute in your u and you want to substitute in your du so that you can integrate with respect to u, okay? And then once you do that, you'll be able to plug back in terms of x and be able to find your indefinite integral. But what you notice here is that I am able to plug back in u, but for dx, I just have 1 dx. I don't have 2 times dx. And so what I'm going to do is I'm going to force a 2 to appear by multiplying by 1/2 and multiplying by 2. So you'll see what I mean here. So I'm going to rewrite my expression, and then I'm going to multiply by 1/2 and then multiply by 2. And then times that by dx. And so what you notice is that looking at the left hand side of the equation and the right hand side, they're the exact same expression, right? Because if I simplified the right hand side by multiplying 1/2 times 2, I would get exactly what I have on the left. But the whole purpose of me doing that is because now I can substitute in my du, right? Because this part is my du. And then here, we see that this part is my u. Okay, and so now what I can do is say, okay, this is the integral of u to the fourth times 1/2 du. Okay, so now what I want to do is just integrate this expression here. And so what I notice is I have a function times a constant, right? I have u to the fourth times a number, 1/2. So I'm going to use my properties to copy the constant times the integral of the function. And then from here, I'm just going to integrate u to the fourth using the rules that we know, right? I need to add 1 to the power and then divide by that same power and then add a c. And then simplifying this here, I get that this is 1/2 u to the fifth divided by 5 plus c. And then multiplying across here, I have u to the fifth divided by 10 plus c. Okay, now what I notice here is that this part is in terms of u and not x. So what I'm going to do, sorry, once I can write my 5. So what I'm going to do is I'm going to just substitute back in 2x plus 1 for u, right? Because going back, looking to the left, you see highlighted in yellow that I let u be equal to 2x plus 1. And so this is just going to be equal to 2x plus 1 to the fifth power divided by 10 plus c. And so this would be my final answer.